Hey everybody, it's Mr. Cozad again with another video lesson. Today's topic is using the quadratic formula and the discriminant. If you're one of my students currently, that's based on section 4.6 in your textbook. If you're not one of my students, man, that's awesome that you found the video. You probably found it online by searching quadratic formula and discriminant, which means you probably have some questions on how to use the quadratic formula and the discriminant in particular. So I hope you find this to be helpful. Okay, the way I design these videos are for you to be able to go through it at your own pace, which means if you need to go back and re-watch a section, you can. If you need to pause the video and work on some problems by yourself and then come back and pick it up, this is totally up to you. You can pace yourself however you choose to do this. So here we go. Let's jump right in. So hopefully, as an Algebra 2 student, you know what the quadratic formula is. If you forgot the quadratic formula, it's really, really easy. You can Google search it really quickly, and you find that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we'll talk about the discriminant in a little bit, but this is the quadratic formula. Now, there's one condition that has to be true in order for you to be allowed to use the quadratic formula. And that one condition is that the equation that you're given must be in standard form. And again, if you don't remember, standard form is ax squared plus bx plus c equals 0. So once you get an equation in standard form like this, it's totally fine for you to use quadratic formula. Okay, so let's actually practice one of these problems here. So here's example one. Best notes in the whole world. What I would do is definitely, as you go through this video, is I would write down each one of these examples with the directions included, so that when you look back on it later, you know what it was that you were working on. So example one is to solve for x using the quadratic formula. And we have 3x squared minus 8x plus 12. So if you remember from the last slide that I showed, the one condition that has to be true in order to use quadratic formula is your equation has to be given in standard form. So what you have to decide first is 3x squared minus 8x plus 12 equals 0 standard form. This one's actually pretty easy. It is in standard form. There's no work that you need to do to get it in standard form. It's already set up the way that you need it. So you're able to jump right in and start applying your quadratic formula. Okay, so we have x equals negative b. Okay, now in this case, b is already negative. So when you drop a negative 8 in for negative b, the two negatives are going to actually cancel out. So negative 8, that's easier just to write 8. So we have 8 plus or minus a big radical. Okay, the first thing in the radical is going to be b squared. So negative 8 squared is 64 minus 4 times a, which is 3, and times c, which in this case is 12, all over 2a, 2 times 3. Okay, so what I always do is I'm really good at math, and I've been doing this a long time, but even still, when I do quadratic formula, I write it out like this so that I can actually see that I've plugged everything in correctly before I start to do some arithmetic. And I've noticed that students a lot of times make mistakes because they try to rush through some of this step here to save some time, and they end up making a pretty careless mistake. They miss a sign, they miss an easy multiplication. So I've found, and I teach, write it out first and then go through and simplify. So here we go. Let's actually do some simplifying. So I'm going to leave that 8 alone. So we have 8 plus or minus the square root of, you can actually go through and plug all that stuff in. 64 minus 4 times 3 times 12, and you should get negative 80 all over 6. Now, I don't know what other teachers expect, but I definitely would not allow you to stop here as your answer, because the square root of negative 80 can be simplified. Okay, if you're one of my students, in our last lesson from 4.4, I guess it was 2 lessons ago, we learned how to simplify something like the square root of negative 80. Okay, this is going to be a complex solution, meaning we're going to introduce the imaginary unit. So what we can do there is 80, first of all, is not a perfect square. So, but we can break it down to the product of a perfect square in another number. So what I'm going to do is I'm going to do negative 1 times 16 times 5. Negative 1 times 16 times 5. 16 times 5 is where I get 80, and I pull out the negative with the negative 1. okay? Now the whole purpose of doing that is this 1 is going to slide out of the radical as an I. This 16 slides out of the radical as a 4. So if I put that all together, here's what I've got. I'm running out of room a little bit here. Let's see if I can squeeze it in there. I get 8 plus or minus 4i root 5 all over 6. This is much better, okay? There's only one really small thing that I would have you do to simplify this further. So a little trick. So everybody look at this. You notice how 8, 4, and 6 all have a common factor of a 2? Well, you can actually factor a 2 out by dividing all three of those coefficients by 2, and you get 4 plus or minus 2i root 5. Leave the root 5 alone. You can't divide that by 2. All over 3. And that would be your final answer. Okay? So, super basic. You've probably been doing problems like that in Algebra 1. That's not really new. That's more or less review. Okay? So, we'll transition next to maybe something that is a little bit new, and we'll talk about the discriminant. Okay? The discriminant here, let me make that a little bit bigger. The discriminant is actually just what's inside the radical in the quadratic formula. If you look back at the quadratic formula, what's inside the radical here, b squared minus 4ac, that's what we're going to call the discriminant. Okay, so that's our discriminant. And there's a couple things that we can actually do with the discriminant. Okay, there are actually 3 different types of discriminant that you can have. Okay, so here's scenario number 1. Scenario number 1 is, let me get my selection tool, there we go. Scenario number 1 is where b squared minus 4ac, so the discriminant, when you plug in your values based on your equation, you get a number greater than 0, so numbers that are positive. Whenever you have a discriminant where you've got a discriminant that's greater than 0, a positive value, okay, that's going to tell you 2 real solutions. There's going to be 2 real solutions. That means real numbers that you've learned about really your whole mathematical career. This does not mean they have to be whole numbers. They can be fractions, they can be decimals, they can be irrational numbers. They're just going to be real numbers. Okay? And in this scenario where your discriminant is positive, your discriminant is greater than 0, there's actually a bonus application point. Here's the bonus. The function that you're using can be factored if the discriminant is a perfect square. Okay, so if you actually find your discriminant b squared minus 4ac and you get something like 36. 36 is positive, so that tells you there's 2 real solutions. And more specifically, 36 is a perfect square, so that's a hint to you that that equation that you were dealing with could be factored. Okay, could be factored. So that's kind of a bonus tip of a way that you can use your discriminant in this particular case. Remember, this only applies if your discriminant is positive. Okay, this doesn't apply for the other scenarios. Okay, so let's look at scenario 2. So scenario 1 was if the discriminant was greater than 0. Scenario 2 is what happens when the discriminant is less than 0. So you do b squared minus 4ac and you get a number less than 0. Whenever that situation occurs, you're going to get 2 complex solutions. Complex numbers, if you remember, are complex because they've got a real component and they've also got an imaginary component. So what you'd be looking for here is somewhere in this problem you're going to have an I, because you're going to be asked to take the square root of a negative number. So that's a signal to you that you're going to have 2 complex solutions. Okay. Scenario 3 is actually, so we've got greater than 0 in scenario 1. We've got less than 0 in scenario 2. It doesn't take a rocket scientist to figure out that in scenario 3, you're looking at a discriminant that is equal to 0. Okay, it's actually equal to 0. And in this particular case, that's a signal to you that you're going to have exactly 1 real solution. Exactly 1 real solution. In other words, if you have exactly 1 real solution, that's a signal to you that the vertex of your parabola is on the x-axis, okay, which is a signal, of course, that we learned in class, that you have a perfect square trinomial. So if your discriminant equals 0, that's a signal to you that the original function you were looking at is actually a perfect square trinomial, and that you can factor that. You definitely can factor perfect square trinomials. Okay, so let's actually practice a little bit with using those discriminants. Okay, so here's example 2. Again, really good idea to write all this down. Example 2 says use the discriminant to classify the solutions to each function. Okay, and I gave you 4 different functions here, and I'm going to ask you to just simply find the discriminant and tell me what type of solutions you have. So examples of your answers here would be 2 real solutions, 2 complex solutions, exactly 1 real solution, things like that. So what I would do is pause the video now, and I want you to practice each one of these 4, finding the discriminant, and see how you can kind of work your way through that. Okay, whenever you've done all 4 and you think you've written out both the discriminant and what that discriminant tells you about the number and type of solutions that you have, hit play again and I'll go through the solutions with you. So pause it now and come back when you actually have it done. Okay, welcome back. Hopefully you actually listened to my advice and paused the video when you needed to and actually worked on this a little bit. Let's go through each one of these and I'll show you the solution. Okay, so for example A, for 2A, what I got for the discriminant should be negative 15. Negative 15 is obviously less than 0, which signals to me that there's 2 complex solutions. 2 complex solutions here, which basically that means if you looked at the graph, you would not see any x-intercepts. That parabola would open away from the x-axis. It would never touch the x-axis. Okay, so let's hopefully you're 1 for 1. Let's see if we can get the next one. So B, this discriminant that I had here was 0. Okay, so that is a signal to you that there's exactly 1 real solution. Okay, and then kind of a follow-up question that I didn't mention to you, but you can answer right now is this factorable? Okay, is this factorable? Okay, so you got to think back to what we said. So if the discriminant is 0, that's a signal to you that 4x squared minus 52x plus 169 is actually a perfect square trinomial, which means yes, the perfect square trinomial is factorable. Again, I know it's yes because my discriminant equaled 0. Okay. Hopefully you're 2 for 2 at this point. Let's move on to C. Here's the discriminant that I had. The discriminant should be 33, okay, which is a whole number greater than 0. So that's an indicator to me that I have 2 real solutions. So if I graphed this function, I would expect to see 2 x-intercepts, or that parabola intersect the x-axis at 2 places. Now I'll ask you that same question again. Is this particular scenario factorable? Okay, the answer you should come up with there is that no, it's not, because is 33 a perfect square? No, it's not. Okay, so it's not factorable. All right, and the last one, D, hopefully you go 4 for 4 here, and we get the discriminant to be 289. Okay, 289. That's a whole number that's greater than 0. Okay, so it's positive. So we get 2 real solutions because the discriminant's positive. And that same question, is this factorable? You might have to think a minute about 289 if it's a perfect square or not. It shouldn't take you too terribly long to come to the conclusion that yes, it is a perfect square. Okay, 289 is a perfect square. Therefore, that is a factorable quadratic. There's a lot of ways that you would have learned in my class, and hopefully if you're not my student, your teacher taught you lots of ways to factor that as well, but that is a signal to you that that could have been factored from the beginning. Okay, so that's another way that you can actually use the discriminant, which is a part of the quadratic formula, in the context of a problem. Now, the last problem we're going to do together is honestly kind of fun. It's kind of a cool application, kind of unique application to quadratic formula that I really enjoy when I write tests and quizzes. So this is a really great problem to be able to understand. So example 3 is write a quadratic function that would produce the following solutions. Okay, write a quadratic function that would produce the following solutions. So what we're actually doing here is I'm giving you the solutions that you would get essentially after using the quadratic formula, and I'm asking you to work backwards to write a quadratic function. The direction should say in standard form, but I'll add that in standard form that would produce these solutions. So you're essentially trying to find an A value, a B value, and a C value that would, you're pulling an A and a B and a C value out of the solutions that you see here. Okay, so what I would suggest doing, honestly, is the very first thing is to think about the denominator 10. Okay, think about the denominator 10. Well, in your quadratic formula, what is the denominator in the formula? Okay, hopefully you said 2a, and if you said 2a out loud, it's not awkward, it's not weird, it's okay. It's okay to answer the questions that I ask out loud. No one's going to judge you. I'm in my kitchen right now talking to myself, It's really strange, so it's okay if you're talking to yourself too. All right, so here's what we know. We know that the denominator is 2a, but we know in this case that it equals 10. So if you take 2a and set it equal to 10, it doesn't take you very long to see that one possible a value could be a equals 5. Okay, so I go and I add that to my list. I figured out that a is 5. Okay, so then what I can do next is I can take, again, if I look at my quadratic formula, I'll go back to it. Okay, it's negative b plus or minus the square root of b squared minus 4ac on the top. Okay, so if I go back here, I know that this first number, negative 12, needs to equal negative b. Negative 12 should equal negative b. Well, if I take those two negatives and cancel them out, I end up getting very clearly that b should be 12. So there you go. There's a b value that would work here. Okay, you could have b is equal to 12. Now, finding a and b in a problem like this is actually the easy part. Finding the c value is the one that's a little bit more complicated. Okay, finding the c value is the one that's a little bit more complicated. So let me get rid of some of this stuff here if I can. I don't want to get rid of all of that. We'll be fine. We'll just make room here. Okay, so here's what needs to happen. It all deals with the discriminant. Okay, now if you look here, this 4 is outside of the radical. Does everybody see that? The 4 outside of the radical? Well, if I wanted to take this 4 and I wanted to put it back inside the radical, how would it go back in? Would it go back in as a 4? Hopefully you know that it doesn't go back in as a 4. If you want to put it back in the radical, you actually have to square it. So it's going to go back in as a 16. Okay, it's going to go back in as a 16. So what we'd actually do next is we would take 16 times 19, and we get 304. Okay, so 16 times 19 is 304. So what I can really do is I can think of that radical as the square root of 304. But I know from my quadratic formula that that also equals b squared minus 4ac. And more specifically, okay, I know that b squared minus 4ac equals 304 because that's my discriminant. And I've already identified an a value and a b value. So here's what we can do. If you know that b squared minus 4ac equals 304, you know that, and you already know that b is 12. We know that 12 squared is 144 minus 4 times a, which we already have identified as 5, and c is the only thing we don't know. We know that that has to equal 304. Okay? So if I clean that up a little bit, I'm going to subtract the 144 on both sides. Okay, I'm going to subtract the 144 on both sides. So 304 minus 144 is 160. Okay, so 160. And negative 4 times 5 is negative 20. So I have negative 20c equals 160. So then, to solve for c, all you have to do is divide both sides by negative 20. And we settle at negative 8 for our c value. Negative 8 for our c value. Okay? So here's what we've done. We've identified our a value, our b value, and our c value. So now what we can do is we can put it all together and write out our function. So our function could be 5x squared plus 12x minus 8. 5x squared plus 12x minus 8. Again, this is kind of a very unique application of quadratic formula where you kind of work backwards, but I absolutely love problems like this because it really requires you to have a pretty deep understanding of quadratic formula. Okay, so that's all that I have for you. If you have more questions or want to let me know what you think about the video, please let me know. And that would be awesome. So thank you so much for spending your time with me. I hope you found this to be helpful, and I'll see you next time.